Okay, this related rates problem says that the light at the top of a lighthouse situated 3 kilometers off of a straight shore rotates at 6 revolutions per minute. How fast does the beam sweep along the shore when the angle between the beam and the shore is 40 degrees? Okay, so here we go. Well, first of all, let's write it out like this. What do we know? Well, we know we've got this lighthouse here. Okay, it is 3 kilometers off of a straight shore. So straight across to it, a perpendicular distance across here is going to be 3 kilometers. And it is rotating. Okay, so it's going to send out a beam here. And that beam is rotating here. Here's our theta. D theta by dt. Now that's 6 revolutions, okay, per minute. Now we are always going to be in radians in calculus here. So now I know that there's a degree measure given to me right here. I'll play with that in a second. But 6 revolutions per minute is going to be 12 pi radians per minute, because each revolution is going to be worth 2 pi radians here. I'm asking how fast it sweeps across the shore when the angle between the beam and the shore, okay, when the angle between the beam and the shore, that's that angle right there, okay? So I'm looking for this at that instant that's 40. Now that, however, when I talk about d theta by dt, it's not that angle that I'm talking about, it's this angle I'm talking about. So I got to think here, when this is 40 degrees, what is this? Well, at that particular moment here, that's going to be 50 degrees. So I'm looking for this at the moment that the angle theta is 50 degrees, but I want to convert that to radians. So I'm going to multiply by pi over 180. There's my conversion factor. And so now I'll just simplify this as much as I can, which isn't going to be much here, but this will be 5 pi over 18. Okay. Best I can do here is cancel out those zeros there. So that's the specific angle that I'm looking for. Okay? Now, let's go through and let's identify what I want here. I want to know how fast the beam is sweeping across the shore here. So let's throw a variable here. Let's call this x, that distance right here. I want to know how fast that's moving. So this point here will be considered stationary. That's not moving. That's straight across from the lighthouse. So the rate at which that beam is moving here is going to be how fast that x is changing. So what I want here is dx by dt. That's the thing that I don't know. Okay, so let's take a look at this. This is the theta that I'm interested in. Here's the x. This is the variable that I'm interested in. And then I've got this constant here, k. Well, what trig function relates those three? And the answer is it's going to be tangent. So the tangent of theta is going to be x over 3. Okay, let's zoom in a little bit here. Tangent of theta is going to be x over 3. So now I'm going to take the derivative of this. Okay, the derivative of tangent will be secant squared of theta d theta by dt. And this is going to equal 1 over 3 dx by dt. I got to take the derivative implicitly with respect to time. I am looking for dx by dt, so I'm going to put this over here, dx by dt, because I know we like to have it on the left-hand side. Multiply it by the 3. This will be 3 secant squared of theta d theta by dt. Okay, so now I'm going to plug in all the information that I've got here. I know that this is going to be 3 secant squared of, well, I've already established what that angle is. It's going to be 5 pi over 18. And again, I plug that in now after the derivative because that angle changes. Okay, that's a variable that changes. I want to take the derivative to explore that change and then plug in a specific value. Okay, I don't want to plug that specific value in too soon, or else I imply in my work that it doesn't change. Okay, so there we go. And I know that d theta by dt is going to be 12 pi. Now, a lot of times you're asked a question like this. Many cases, this ends up being a unit circle
angle. Like it could be pi over 3, pi over 4, pi over 6, something like that, okay? So where you don't really need the calculator to evaluate this. But here, I don't recognize 5 pi over 18. I'm not sure what that is in terms of a ratio for this. So,
I mean, if I wanted to quote unquote simplify this, I suppose the best I could do here is say that this would be what, 36 pi secant squared of 5 pi over 18. Okay, kilometers per minute, because those are the units I'm working with right now, okay? The angle here is changing per minute, okay? We got the 3 kilometers here, so it's going to end up being kilometers per minute here. Now, that's not really all that instructive, okay? So we're going to go to the calculator now and plug this in. I got to make sure I'm in radian mode though, because I've got my angle here in terms of radians. So this will be 36 pi divided by the cosine, okay, of 5 pi divided by 18, and I'm going to square that. And so the answer here is this is going to be sweeping across the shore at 273.7 approximately. I'm rounding that. Okay, kilometers per minute at that moment. Okay. Now, like I said, sometimes you're going to get angles, oftentimes you're going to get angles in there that are going to be these nice unit circle ratios here. But what I wanted to accomplish with this was to indicate here that if you don't get an angle like that, it's a very simple thing to do to just convert that to radians, okay? And then you just move from there.